Chapter 16, Lesson 2. How do forces interact?
Big picture. Lesson 1 was all about how forces affect us. In Lesson 2, we'll be exploring how forces interact. In Lesson 3, we'll look at what gravitational force is.
What is force? In physics, force is a push or pull on an object. A force can cause an object to accelerate, slow down, remain in place, or change shape. How is force measured? The unit of measure for force is the Newton, which is abbreviated as capital N. 1 Newton is the force needed to accelerate 1 kilogram of mass by 1 meter per second squared. The formula is N equals 1 kg times m over s times 2. Other units of force include the dyne and the pound force.
What is acceleration? Acceleration is the measurement of change in an object's velocity. When you press down on the gas pedal in a car, the car surges forward going faster and faster. This change in velocity is acceleration. Acceleration also has a direction, which means it is a vector. There on the screen before you, you see the formula for acceleration. When an object is changing velocity by a constant amount over time, this is called constant acceleration. An object with constant positive acceleration will be going faster and faster. Its velocity will be increasing constantly.
Freefall, a type of acceleration. One example of constant acceleration is an object in freefall. During freefall, gravity applies a constant force on the object, causing a constant increase in velocity. If you measure the distance an object fell each second, it would fall further because it is constantly picking up speed.
Force, mass, and acceleration. Force can be figured out if you know the mass and acceleration of an object. This equation comes from Newton's second law of motion. Force equals mass times acceleration. Forces and vectors. Force not only has a magnitude, which is what we get in newtons when we use the equation above, but it also has a direction. This makes force a vector. Vectors are shown by an arrow that indicates the direction of the force and a number that indicates the magnitude.
Forces in equilibrium. Sometimes there can be many forces acting on an object, but the object remains still. In this case, the forces are in equilibrium or balance. The sum of the forces, or the net force, is 0. The picture below shows an object sitting on a table. The object isn't moving. This is because the force of gravity pulling the object down is equal and opposite to the force of the table pushing up. The net force is 0, and the forces are in equilibrium.
Combined forces. When multiple forces are acting on an object, the resultant force is the sum of the vectors of the individual forces. Take, for example, a tug of war. The two sides are each pulling. If one side is pulling with a force of 2 newtons in the left direction, and the other side is pulling with a force of 3 newtons in the right direction, then the resultant force is 1 newton in the right direction. Types of forces. Friction. A force caused when one object rubs against another. It works in the opposite direction of the main force. Gravity. A force caused by a large object, such as a planet. Tension. A pulling force that is exerted by a string, cable, or chain on another object. Elastic. A force exerted by an object trying to return to its natural length. Think of a rubber band being stretched. It is trying to return to its original size. Nuclear. A force that holds atoms and their particles together. Electromagnetic. Can pull or push, associated with magnetic and electric fields.